Have you ever pondered the mystery of how stars, those magnificent pinpricks of light in the night sky, come into existence? The process is as fascinating as it is complex, a cosmic dance of elements and forces that results in the birth of a star. In the vast interstellar medium, giant molecular clouds, composed primarily of hydrogen gas and dust, exist. These clouds, immense and cold, are the nurseries of stars. Instabilities within these clouds, perhaps triggered by the shock wave of a nearby supernova, lead to the formation of denser regions. Over time, the overwhelming force of gravity causes these denser regions to collapse, creating a fragment known as a protostar. The collapse of the protostar generates heat, and as the temperature and pressure in its core increase, a process known as nuclear fusion begins. This is the heart of a star's life-giving energy. Hydrogen atoms under immense pressure and heat come together to form helium, releasing energy in the process. This energy halts the gravitational collapse, establishing a delicate balance between the inward pull of gravity and the outward push of radiation from the core. This marks the birth of a main sequence star, like our own sun. Stars spend the majority of their lives in this main sequence stage, steadily burning their hydrogen fuel. The size, color, and lifespan of a star depend on its mass. Larger stars burn brighter and hotter but have shorter lifetimes, while smaller stars like red dwarfs burn their fuel much more slowly and can live for billions of years. Eventually, however, every star exhausts its hydrogen fuel. When this occurs, a star expands and cools, becoming a red giant or supergiant. In their cores, heavier elements like carbon and oxygen are formed through fusion. For stars more massive than our Sun, this process continues until iron is formed, at which point the fusion process is no longer energetically favorable. The end of a star's life is as dramatic as its birth. Stars, less massive than the Sun, will gently expel their outer layers, forming a planetary nebula, and leaving behind a white dwarf. More massive stars, however, end their lives in spectacular supernova explosions, scattering their enriched material back into the interstellar medium. This material will then become part of new stars, planets, and potentially life. So the next time you look up at the night sky, remember, each star is a cosmic crucible, a testament to the power of gravity and nuclear synthesis. They are born from the dust and gas of the interstellar medium, shine brightly as they fuse hydrogen into helium, and die in a blaze of glory, only to sow the seeds for the next generation of stars.